Hello everyone, welcome to Chemistry Connections with Mr. Ramsey. In this video, we're going to put everything together that we've learned in the first 3 stoichiometry videos. So what we're going to be doing is converting between grams, moles, and particles. So let's go ahead and get started. What you're seeing here is called a mole map. And it's one way that you might find helpful for making the types of conversions that we're going to be doing in this video. You can see that to convert the mass in grams to moles, you would need to divide by the molar mass. And if I had the moles and I needed to convert to mass, I would multiply by the molar mass. I've shown this in previous videos using the ladder method. Now for moles to particles, you'd multiply by Avogadro's number, 6.02 times 10 to the 23rd. And to go from the number of particles to moles, you'd have to divide by Avogadro's number. Now you notice that you can't go directly from mass to number of particles. You have to make that step in between. You have to convert to moles. And for particles, if you had to convert those to mass, you have to go to moles first and then to mass. Okay, let's take a look at some examples. In this example, we're going to convert 2.5 grams of sodium chloride to particles of sodium chloride, or more specifically to formula units of sodium chloride. So I'm going to start this problem using the ladder method, and then after I'll pause, and then I'll show you how I could solve the same problem using the mole map. Okay, so 2.5 grams of sodium chloride. I'm going to draw my ladder. I'm going to have 2 parts to my ladder here. And I know I'm going to need to put grams. I'm going to make this just a little bit smaller so I have a little more room to work with here, because I'm going to have 2 parts to my ladder. I know that. Because to go from grams to particles, I first have to go to moles of sodium chloride. Okay, now I'm going to set up the whole ladder to get started with. Now remember, I know that the grams have to go in the denominator because the grams to start with, this would be over 1 by the way, need to cancel out. Okay, and then I know that I need to put moles of NaCl in the denominator here so that these cancel out, and I know that I can put the number of particles up here. Okay, now let's go ahead and start filling in some values. So sodium has a molar mass of 22.99. There's only 1 sodium. Remember, in previous videos, we've talked about how if there's no subscript, that's understood to be a 1. Okay, and the molar mass of chlorine is 35.45. So I'm going to go to my calculator. And you can see that when I add 22.99 plus 35.45, I get 58.44 grams. And that's the molar mass. So the way that I would say that is 58.44 grams per mole. Okay, so I'm going to go back. I'm going to put the 58.44. I wanted to round to 2 decimal places. I'm going to squeeze that in there over and put the 1 mole in the top. And I know that 1 mole is the same as 6.02 times 10 to the 23rd particles. Okay, so I'm going to go back to my calculator and I'm going to delete what I have here, and I'm going to type in the 2.5 times parentheses 1 divided by 58.44 grams, and then I'm going to do times parentheses, and then I'm going to do another parentheses because I have the 6.02. The 6.02 times 10, I'm going to do this x to the y, 23rd, close parentheses, over 1, and then another close parenthesis. And I get an answer of 2.5752909 times 10 to the 22nd. I'm going to round that to 2.58 because the number after the 7 in the hundredths place is greater than 50,000. It would be 52,900. And that will be times 10 to the 22nd particles. So I'm going to go back and I'm going to put my answer down here. Whoops. 2.58 times 10 to the 22nd particles. Now I'm going to show you how to solve this same problem using the mole map. Okay, so now I'm going to show you how to convert 2.5 grams of sodium chloride to particles of sodium chloride using this mole map. Now, one thing that you need to remember is that we already determined that the molar mass of sodium chloride, which is 58.44 grams per mole, and I'm going to put my label here. If you're not sure how I came up with that 58.44 grams, just pause the video, back up to the example where I use the ladder method, and you'll see that. Okay, so now I'm going to take and just write out my 2.5 grams of sodium chloride. Now, I need to go from grams to moles before I can go to particles. So I'm going to divide by the molar mass. So I'm going to divide by 58.44 grams per mole. So I'm going to go to my scientific calculator and I'm going to do 2.5 divided by 58.44, and that gives me 0.4277, so forth. I'm going to write down 0.427789. I'm only going to go out so far. Write that out, 0.042778 and we have grams here in the numerator, grams in the denominator. This moles is moles of sodium chloride. And I'm going to scroll down a little bit to give myself a little bit more room. Now I have another part to this problem where I need to now take the moles of sodium chloride that I have and I need to convert that to particles. So I'm here, I want to go to particles. So I'm going to multiply by Avogadro's number. I'm going to multiply by 6.02 times 10 to the 23rd particles. So I'm going to go to my calculator. I left my answer in here. I just wrote down on my sheet some of these numbers so you could see them. And I'm going to multiply by parentheses 6.02 times 10, use the x to the y, so the 23rd power, close parenthesis. I get 2.58, rounding to 2 decimal places. 2.58 times 10 to the 22nd particles, or formula units to be more specific, of sodium chloride. This is the same answer that we got using the ladder method, which is what we would expect. Try the next few questions on your own by pausing the video, and then once you have a solution, you can continue watching the video and see how your answers compare to mine. Okay, to get started with this problem, I'm first going to find the molar mass of ammonium carbonate. Now I'm going to go back through and just put the coefficients that aren't written, the ones. So there's no coefficient after the nitrogen, so there's a 1. And after the carbon, there's no coefficient, so that's a 1. So that means that I'm going to have 2 nitrogens, and the molar mass of nitrogen is 14.01. And I'm going to distribute the 2 to the things that are inside the parentheses, not just the nitrogen, but the hydrogen. So there are 8 oxygens. And oxygen has a molar mass of 16.00 grams per mole. There's 1 carbon. There's no parentheses, so there's no subscript to distribute like there is here. You only distribute when you have some element symbols inside the parentheses. Okay, so there's 1 carbon. I'm going to put the carbon up here. And the molar mass of carbon is 12.01 gram per mole. And there are 3 more oxygen. I wrote oxygen here, but that's hydrogen. That's my mistake. So let me correct that. So there's 8 hydrogens, and the molar mass of hydrogen is 1.008. And there are 3 oxygens, and the oxygen, as I mentioned, has a molar mass of 16 grams per mole. So now I'm going to go to my scientific calculator, and I am going to add up all of these numbers. So let me do that. So I'm going to do parentheses. 2 times the 14.01 for the nitrogens, plus 8 times 1.008 for the hydrogen, plus 3 times the 16 for the carbon, plus, for the oxygen, and now 1 times 12.01 for the carbon. The molar mass for ammonium carbonate is 96.094. And I'm going to round that to 96.09 grams per mole. Okay, now this is not our answer. Remember, we're trying to figure out if we had 3.01 times 10 to the 24th particles, how many grams of ammonium carbonate we would have. I'm going to put my label for the ammonium carbonate underneath here, just so I have enough room to get everything that I need to in my ladder. So let me erase this and let me draw my ladder. Of course, this is going to be over 1. Now, since the particles are in the numerator, I know I want particles here in the denominator. And remember, you can't go from particles directly to grams. First, you have to go to moles. Okay, and these are moles of our ammonium carbonate. The label's important here. It's going to become even more important as we move along and we learn even more about stoichiometry. Now, of course, if I have 1 mole of ammonium carbonate, I have 6.02 times 10 to the 23rd particles. I'm going to change the color of my marker here so it becomes hopefully a little bit more clear because I'm writing over my periodic table here. So I have moles of ammonium carbonate, so I know I want moles in the denominator here. So NH42CO3, and I would have 96.09 grams. So you can see we went from particles, and the particles cancel out here, and we went to moles, the moles cancel out, and we were left with our grams. So the only thing that's left for me to do is to go to my scientific calculator and to start plugging in all the numbers, all the values that we have here, all of these measurements. So 3 times 3.01 times 10 to the 24th power times, I'm going to do 1 over. It's important that you're following along with the way that I'm using the parentheses here. Your calculator is not going to know to follow what order of operations unless you tell it. Okay, so times 96.09. And that's over 1 mole, so I didn't do a parenthesis here. I could, and then divided by 1 and put a parenthesis. But I know that 96.09 divided by 1 is just 96.09. So for convenience, I just left it as you see it. And I hit my equal sign, and I see that that would have a mass of 480.45. So I'm going to put my answer up here. This would be 480 point, what did we say that was? 45 grams of ammonium carbonate. Okay, hopefully you've started to get the hang of this process of stoichiometry. In this next example, we're going to convert 27.5 grams of iron 3 oxide to particles of iron 3 oxide, or more specifically, formula units. Pause the video and give this problem a try. Okay, my first step was just to use the periodic table to find the molar mass of iron 3 oxide. So I looked on the periodic table, found the mass of iron to be 55.85 grams. There were 2 irons, so I multiplied by 2. And then I added the 3 times 16, the molar mass of oxygen, which gave me 48. And I added that all up, and it gave me 159.70 grams per mole of iron 3 oxide. That's the molar mass for iron 3 oxide. Then set up my ladder method, as you see here. I plugged all the values into my calculator. The calculator gave me an answer of 1.03663 times 10 to the 23rd, which I rounded to 1.04 times 10 to the 23rd particles of Fe2O3. I hope that helped, and I'll see you next time on Chemistry Connections with Mr. Ramsey.